I don't know what happened to October weather, but it went like right from like 100 to like 10. I don't know what happened, but it's fine. We're gonna be fine. Just had to make sure to get a sweater today. Um, so first question I have is, does it make sense why I started my table at -5, 0 on this problem? So I gave you a hint so you could get going as you walked in, but I wanted to make sure you could see where I got my -5, 0. And then I chose values for you for x. Did those make sense? Okay, and the reason I picked those is because if I use these, then I know the square roots of those and I don't need a calculator. I sort of cheated and used the a=1 rule. I went up 1 and then up 4 to get things that I could easily square root. Just anyway. So -4 plus 5 is 1. Square root of 1 is 1 times 2 is 2. -1 plus 5 is 4. Square root of 4 is 2 times 2 is 4. Okay, -5, 0, -4, 2, -1, 4. And then you can see your shape of your square root graph. Most of the time when I give you guys square root graphs, I let you use a calculator, but this is a really good way to be able to make a table quickly without a calculator, just for your information. So A is 2, H is -5, K is 0. Vertically, stretched by a factor of 2. Left, wait, I forgot to put the word shift. Shift left 5. And I don't really say anything for K because it's not a shift up or down. It's already at 0. Any questions about number 9? You sure? Okay. All right, go down to number 11. My only sad thing about number 11 is there is definitely not enough room here. So we're going to play with not showing all our work. It's going to be fun. It's going to be a fun game. -8, 1 minus 3v minus 4 equals, whoa, equals -108. Okay, first step, pretend you have equals. Okay, now second step, sub. Okay, so I'm going to do two things. I'm going to distribute over here. So -8 plus 24v minus 4 equals -108. Now I'm going to combine like terms. 24v minus 12 equals -108. Okay, now I'm going to add 12 to both sides, but I'm not going to show it. You're going to be okay. Everyone's going to be okay. And now I'm going to divide by 24 on both sides, but I'm not going to show it. You'll be fine. Okay, -4, open or closed? Open. Now this is one of those problems that just has one dot. And so we just need to test either side to determine if it's the arrow goes left or right. So I'm going to plug 0 in, -8, 1 minus 3 times 0 minus 4 is less than -108. how do I feel like whatever this is going to be definitely not less than 108, negative 108. Negative 108 is a really big number. Okay, so -8, 1 minus 3 times 0 minus 4, -12. False. Definitely false. I didn't even really need to do the math there. That was clearly going to be false. Okay, so false at 0, true everywhere else. V is less than -4. You guys remember how like I was doing the notes for this and I was like, no matter what I say and how many times I remind you, half the class is not going to write the final answer. Guess what? Half the class didn't write the final answer. I don't even know what to do. Like I warned you, I put the stuff, I put a box around it. It said in the directions, solve and state your answers algebraically and graphically. Of course, there are a significant amount of students that on the second problem on the test did not check their answers, even though you're supposed to check your answers every time you have a square root equation and the direction said check your answers. There's a significant portion of people who did not. Just say, I don't even know what to do about it because it's not like I can remind you again. Anyway, fine. Just move on with life. Okay, so we do not have anything in the packet today. You guys can put the packet away. Oh, good. More inverses. This is the fourth day we've been working on inverses. So there's really nothing new today. It's just like bringing it all together, I guess. There is a reminder about how to check your answers. You guys remember we did that the first day and we used the stack function machine. We're going to go over that again today at the end. But everything else is stuff that you're probably confident at, which is not a bad thing. Homework is 45, 46, 47 to 51. And here's my joke. There's the count. And he says today's number is 0. 0 kids are listening to me. Do you guys know the count from Sesame Street? No. He's super cute. He's like the one who teaches the numbers to the little children. Because he's the count. If he counts them. But anyway, I'm like a huge Muppets and Sesame Street person because Sesame Street characters are Muppets, but it's probably my age. Also, do you guys all know you have a quiz tomorrow? And do you know what it's on? Inverses. What else? I see so much smoke coming out of brains right now. Inverses, what else? Yeah, so graphing a non-function, which is either a sleeping parabola or a circle. And then last thing, what are those things called again? I know what they're called. Ryan knows what they're called. No? I'm just gonna put a question on the quiz. What are these called? I'm kidding, I'm not. I already printed it. I'm too lazy for that. They're called same base exponential equations or no, that thing. If you know what they are, but you didn't know what they were called. Well, if you don't know what they are, I suggest that you familiarize yourself in the next 23 hours. Okay, number 39. I don't even know why we're doing this one. It's the easiest problem of all time, but it's fine. So the directions here are to find the inverse. Okay, order of operations, what comes first on number 39? Multiply by 6. This is not challenging. This is not meant to trick you. What comes next? Minus 11. Oh, look, Mrs. Talbot has reached her limit of being able to write out the words for the operations. Okay. Inverse. Add 11. Divide by 6. Start with an X. Add 11. Divide by 6 on everything. Any questions about 39 before I move this down so you can see 40 and 41 better? All right, I'll give you a second. Okay. Notes on inverses. This is pretty much exactly what we did yesterday. We're going to do exactly the same thing. We're going to make the tables, find the inverse equation, domain and range, graph. Okay. What type of function do I have here? What are these called? Cubics. Okay. And what is the inflection point of my cubic? 1, 0. Okay. So let's see. 2 minus 1 is 1. 1 cubed is 1 times 2 is 2. Okay, but when you do this, this is not necessarily symmetric. It is, but a cubic doesn't come back up. It goes down. So we actually have to plug them in, I'm saying. So 3 minus 1 is 2. Cubed is 8. This is going to be large. 16. We won't graph that, but we'll use it to help us graph. Okay, 0 minus 1 is negative 1. Okay, here's a great question. What's negative 1 cubed? Negative 1. Negative 1 times 2 is negative 2. And now you can see where the symmetry comes in. You can use symmetry, but you have to be careful of the signs. Okay, so over here, 1, 0, 0, negative, wait, why did I graph that first? I guess it's, okay, anyway. 0, negative 2, 2, 2. Remember that inflection point's where it gets flat. Okay, now this one has 3 steps. I can tell. It doesn't matter if you can tell or not. But when I plugged things in for X, what did I do first in my table? Parentheses, right? -1. Then what did I do? Cube. And then times 2. So parentheses, exponents, then multiply. Okay, and there's one more bit that we need to make sure to do in blue pen before we move on. Although cubics are my favorite domain and range. You guys know what the domain and range are of every single cubic forever of your whole life? Yeah, all real numbers for both. All right, so that's everything I can do with the blue pen. Now I'm going to switch to the red pen. Cube roots, never my favorite to draw. Just not it for me. Flip my domain and range, that was easy. Okay, so last thing I need to do is reverse my steps and write the inverse equation. So 1, 2, 3 steps, undo from the bottom. So divide by 2, cube root plus 1. Start with an X. Again, I like to put it a little distance away from the F inverse of X just because I can tell one of my steps is going to be cube root. That's going to have to go in front of it. Okay, so step 1 is divide by 2. Step 2, cube root everything. Step 3, +1 on everything. Do I love how this is on 2 lines? No. Do I hate it enough to redo it? No. Do you guys have any questions whatsoever? Anything? Are you completely and utterly sure? Okay, I have a couple of questions for you. Really quick question. Okay. What is the answer to this? What is the answer to this? What is the answer to this? That's the square root of -8. Doesn't matter. It's got an I, right? Okay. It's I 2 root 2I root 2. 2I root 2. Well, do you guys see that this is possible for us to do easily? This is not possible for us to do easily. This, you have to be mindful of negatives. So just be really careful with negatives. Why am I bringing this up? What do you have tomorrow that's important? Quiz, yeah. Do you get to use a calculator? No. So I want to remind you about how cubes and cube roots work with negatives real quick before you're like stranded with no calculator and you're like, oh, I forgot. No, we're good. Okay. I won't ask you to cube root anything challenging, I promise. All right, example 2. I don't even know. I bet your whole class could do this without me, but it's okay. Okay, first question. What is the vertex? First of all, it's a parabola, right? What's the vertex? 3, 2. Gorgeous. And this one I could kind of cheat and use symmetry because it's squared. So 4 minus 3 is 1. 1 squared is 1 plus 2 is 3. 1 minus 3 is -2. -2 squared is 4 plus 2 is 6. Okay, 3 steps. The first thing I did when I plugged something in was I subtracted 3 parentheses. Then I squared exponents. There was no multiply and divide. So the last step was add. Okay, last bit. What's the domain of this parabola? Does it go forever to the left and right? Yes, all real numbers. Does it go forever down? No. What's the lowest point? 2. Y is greater than or equal to 2. All right, that's it for blue pen. All right, steps are next. I don't know why that bullet point is so high, and it's fine. Okay, so undo this first. Don't forget your plus or minus on the square root, super important. Why did I just, I don't. Okay, so F inverse of X equals. Okay, I see that I'm gonna need a square root and a plus or minus. So I'm gonna put my X way over here. First thing is -2, then plus or minus square root, then +3 on everything. This becomes X is, whoa, 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 what is happening on my paper? Man, it's in blue. I grabbed the wrong pen. I have to shut the whole thing down. X is greater than or equal to 2. Now the range becomes all reals. Right, you feel like you're prepared for that quiz problem, I hope. Graphing the non-function should be relatively easy, just have to be really careful with the sleeping parabola, and make sure you understand where H and K are. And also that you understand which way it opens normally and which way it opens if it's negative. And the sleeping parabola up here is a regular one. So typically they open to the right. If it's negative, it opens to the left. Keep in mind that I know you don't have a calculator, so I'm not going to be a jerk about the A value. What's the last thing? Same base exponential. It's like, if you ask questions about that, you should be good. Unless you just get it because it's not that bad. But, okay, moving on. Any questions about this before we? Okay. This is the problem that we just did, by the way, so you don't actually have to worry about whether or not those are inverses. We just did the problem. Okay, so the last bit of inverses, this is the last bit of regular inverses. Tomorrow we're going to start working on logarithms. Logarithms are an inverse of something that we haven't talked about yet. So just hold that thought. This is actually going somewhere new, not just reviewing the same thing for 14 days in a row. I mean, we like that, Mrs. Tyler. Finally feel like we're not going too fast. But anyway, this is gonna go somewhere. There are going to be problems in your like CUDA worksheets and things that are going to say, state if the two are inverses. So they give you two different functions and they want you to figure out whether or not they are inverses of each other. There's three different methods to doing this, and it just depends on your personal preference. But the first, so I want to talk about the three methods and then we're going to do one. The first method is find the inverse of one of them. So literally find the inverse equation of one of them. And see if it matches the other one. This is kind of obvious. Like, I don't even know why I had to put that in words. But one of the ways that you could do this problem is you could start with f of x. You could list the steps. You can list the backward steps, find the inverse, and see if that's g of x. Yeah, Mrs. Tyler, yeah. That's not exactly rocket surgery. Okay. That's probably my least favorite way, to be honest with you. I'm a lazy human. We have discussed this. Okay. So second way, graph both and see if it's a reflection on y equals x, or make tables and see if the tables are flips of each other. There are always people in my class who their first instinct is to go straight to the graphing calculator. Like that's their thing. And they like to guess and check on the graphing calculator, and they want to like go to Desmos, plug things in, and look, this is the method for that. They're gonna go graph both of them on the graphing calculator, inspect the tables, see if these tables are flipped, take a look at the graphs and see if they look like a reflection. The only warning I have for you, And there was a student, I can't remember who it is, who redid something on his test because he was confused by the fact that this is a rectangle. And so the spaces between the X values are farther apart than the spaces for the Y values. And do you remember the problem on the test where it was like the parabola and the line going through it? And you had to find the points of intersection. It was the last one on the test. You had to do it algebraically and graphically. He graphed them both on the graphing calculator because the aspect ratio of this is a rectangle, not a square. He thought his answer was wrong and like redid the whole problem wrongly. So my thing is, if you're going to do that method, just keep in mind that your calculator is a rectangle and it might not look perfect when you turn it 45 degrees. Okay, last method, and this is my favorite. Is the stacked function machine method. We already did this once. We did it in problem number 1 days ago. And what I'm saying here, be careful of the domain. Like if you were going to start with plugging something into g of x, you got to be careful that you're not going to get a negative under the root or divide by 0. So just keep that in mind. If you get something weird, just pick a different number. Okay. Last one, 43. We're going to do this dealio here. Okay, I'm going to do the stacked function machine method for this because I like it so much. And I know you guys can do the other ones, although these are harder to find the inverse. I'm just going to pick 0. We're going to see if it works. I like to try 0. Sometimes 0 works, sometimes it doesn't. It just depends on the type of function you have. But you would know. So 3/5 times 0 minus 15 equals negative 15. Okay, so stacked function machine says take your answer, your output, and put it in the other one. So now I'm going to take that negative 15. And what am I looking to get back out? If these are inverses, what should I get back out? Yep. And the question is 5/3 times negative 15 negative 25? It is. You can tell because 3 and 15 make 5. So you could divide that real quick. Got negative 5 times 5 is negative 25. Okay, now scroll back up here. You did not leave as much space as me. It's okay, just shove it over in the corner. Okay, we're gonna test our theory. here. And I saved this one for last because the domain is more important. Let's try 0. It might work. Is that really 11? Yeah, okay. I'm going to tell you not to get too hung up on the plus or minus there. As a matter of fact, did I already tell you that you have worksheets on this, like CUDA worksheets? They're going to avoid the squares anyway because of the plus minus. So don't get overly worried about that. So, do you have any questions about any of this stuff? Stack function machine is fine. Try 0. If you get stuck somewhere because of a negative under a square root or a divide by 0, just pick a different number. Just erase it and try like 5, 7, 10, something else. No big deal. Okay. That's it, I think. I will be open over here for the next few minutes in case you have questions about your quiz review or anything.